Welcome to VVork. This is the continuation of a video series where we're discussing containers, Docker, Kubernetes, and VMware PKS with Marc Alumbaugh. In this video, Marc will discuss the logical topology of VMware PKS and NSX-T. Let's get started.
So what we have inside Kubernetes when we spin up a Kubernetes cluster, and you could see in the upper right-hand corner here, I'm illustrating that you could deploy a series of Kubernetes clusters. Maybe one cluster is for production, maybe another cluster I'm going to use for quality assurance, or another one for top secret, or another one for unclassified. It's up to you as to how many clusters your business workload's going to need.
Is it possible to use those clusters in effect to set up a multi-tenanted capability, or should I
Absolutely.
think of these as clusters? Okay.
That would be another use case. It's a good question. It's an excellent question. I could be using them to do some type of multi-tenancy, maybe customer A, customer B, customer C's, or department A's, department B's, department C's clusters, so you could be segregating each of whatever your respective customers are. This is a logical view. There's other things that we go into when we go into the enterprise PKS class. We go over the physical topologies, what they look like. This is one sample of a logical topology. I could be routing or switching into each of these segments in my clusters, and they each have their own set of planning that you would have to do when you go through laying out how you want your cluster to look. What ends up happening on each of your Kubernetes clusters is an important piece to be aware of is down here at the very bottom. This is where my masters, we're showing you three here, we're showing three masters, and my worker nodes are going to be. My worker nodes over on the right-hand side here is where my pods or my containers are running at. Now, as we start to deploy our workloads, you got to start asking yourself a question. Do I want pod 2, 3, and 5 here, which I've just kind of circled? What type of restrictions do I want between those pods when it comes to communication? What ports do I want to allow through? What ports do I want to allow in to those pods? Do I want cross-pod, cross-functionality communication to be in play? And then the question is how are you going to control that? How am I going to handle things like load balancing when you do microservices? If you need more power, it's different than a virtual machine. A virtual machine, normally what I would do if I want more power is I would edit settings on it and add more CPU and add more RAM. Containers in cloud native works much differently. What we do instead is we scale out, we scale wider. So instead of having one front end VM, I have 5 front-end containers. If I need more horsepower, then I just simply say, well, fine, I'm going to 10 front ends. Or if I need more resilience, maybe I'll scale those across different physical hosts. So I'm guaranteed that my blast radius would be smaller if I lost, let's say, a particular physical server that's running my workload. So you scale out wider. Well, as you scale out wider, you're going to need to have a load balancer to be able to load balance across them and doing their respective health checks. So when you're looking inside the enterprise PKS solution, you're going to see this thing referred to as the NSX-T container plugin. We refer to it as the NCP. The NCP is the piece that's doing this integration between Kubernetes and NSX-T components. It runs on all the master nodes. you could see in the illustration of this box down here is it's got a hook between the Kubernetes API server, and when commands come into the Kubernetes API server, the NSX-T container plugin is watching the creation, addition, or the changes that are being reported by the Kubernetes API. What type of things would be happening here is, let's say I want to deploy a new application. I would actually be sitting over here as an administrator or a developer, and I would send a Kubernetes command into the cluster. I would do something like kubectl apply -f and then my manifest file, which would be all the details about my deployment in my application. So I would be saying which containers do I want to be deployed, how many of them, what ports are being used, etc. The NCP that's sitting over here is seeing the addition of that. Hey, this guy needs to deploy something. Does he need his own network? Does he need a load balancer? Does he need an ingress controller? Does he want to apply firewall rules? It's the NCP then in turn that goes over to the NSX-T manager, and he's going to go in and he's going to say, hey, I need a new logical switch. I need a new load balancer, and he'll actually handle automatically for you the creation of those respective objects.
In the next video, Marc will discuss PKS network security with NSX-T. Join us in the next video to learn more.